2 seconds. So as long as it's quiet, I'll leave this open to keep it cool and keep it. And Minkowski spacetime and Lorentz invariance.
Okay. Hello. Thank you all for coming. So Minkowski spacetime and Lorentz invariance, the cart and the horse, or two sides of a single coin. This is based on a recently published paper. It's available online, and if you wanted, I can email it to anyone who sees it. Okay, first things first. This talk is about a debate. It's a critical assessment of a debate. And what are the essentials of this debate? And why would we speak of the cart and the horse with respect to Minkowski structure and Lorentz invariance? Because there is this debate between, on the one hand, Harry Brown and Oliver Pooley, and on the other hand, Michel Janssen. So, what the debate about? This is the way that Michel Janssen put it. It says that our central disagreement is a dispute about the direction of the arrow explanation connecting the symmetries of Minkowski spacetime and the Lorentz invariance of the dynamical laws governing systems in Minkowski spacetime. I argue that the spacetimes, Michel Janssen of course, I argue that the spacetime symmetries are the explainers and that the Lorentz invariance of the various laws is the explanandum. Brown argues that it is the other way around. So, in a nutshell, Janssen says Minkowski structure explains Lorentz invariance. Brown and Pooley say the arrow points in the opposite direction. Okay, let's start with the so-called dynamical interpretation, Brown and Pooley, namely that Lorentz invariance explains Minkowski spacetime. The main motivation for this view is a sort of critical assessment of a naive conception. Sorry. It's okay. The main motivation, or one of the motivations for this interpretation, is a critical assessment of a sometimes assumed and more or less widespread naive conception of the way in which Minkowski spacetime is supposed to explain dynamical relativistic effects. For example, there are some people that say that free particles follow the rats and grooves, geodesics, of Minkowski spacetime, just as a iron sphere follows the groove on an inclined plane. That's more or less the idea. It's a sort of pseudo-causal explanation. Brown and Pooley say that this cannot be true, this cannot be correct, and they pose two arguments against it. One has an ontological flavor. It goes something like this. The standard explanation of dynamics by means of Minkowski spacetime structure is mysterious and problematic. Even assuming that there is a self-standing Minkowski spacetime, we wonder how physical objects get to know that spacetime has a particular structure, so that they can behave in the way that this spacetime indicates through its structure. Physical objects, this is the main point, physical objects do not have spacetime fields. The second argument is more of a logical vein, and it goes like this. Even assuming that there is a self-standing spacetime again, with a certain chronogeometric structure, this does not formally determine that the dynamic symmetries of the laws postulated by the theory have to mirror such a structure. And we actually have historical examples of something like this. In Lorentz's theory, the background spacetime structure is Newtonian with Galilean symmetries, whereas the symmetries of the dynamical laws are the Lorentz transformations. So there is a mismatch there. Okay, given these two arguments, they say that a much better conception of the issue is the following. The appropriate structure is Minkowski geometry precisely because the laws of physics are Lorentz covariant. Again, Lorentz invariance explains Minkowski structure. One important subtlety in this approach is the following. The idea is more or less the following. fundamental quantum laws may provide an explicit physical foundation for Lorentz invariance. But at the moment, in our state of physics, Lorentz invariance in quantum field theory and other fundamental quantum theory is written by hand. It's not a result of the main equations of the theory. However, in the meantime, a truncated form of the interpretation can be assumed. We can endorse the dynamical view that Lorentz invariance explains Minkowski's structure, Minkowski's spacetime, leaving aside the detailed description of how the quantum microstructure of matter instantiates this Lorentz invariance. This will be important for my conclusions, so keep it in mind, please. Okay, the other corner, the other side of the debate, the other position, Janssen's. First of all, Janssen's position is not at all this naive, pseudo-causal, problematic interpretation that Brown and Cooley criticized. It's more subtle. His main idea is that relativistic effects have their physical foundation in the standard, in the normal, the default spatiotemporal behavior of physical objects, and this standard, normal, default spatiotemporal behavior is encoded or expressed by Minkowski spacetime structure. Therefore, Minkowski structure explains Lorentz invariance. In his own words, Minkowski spacetime explains relativistic effects by showing that they need no explanation. Or, to put it less paradoxically, the statement that spacetime is Minkowskian explains all of them in one fell swoop. It commits one to assigning all manifestations of Lorentz invariance to the class of kinematical phenomena. Okay. That for Janssen, and for the debate. What I will do now is to show that there are two very important, crucial assumptions explicitly shared by both parties in the debate that are rather problematic. First I will explain them and then I will challenge them. The first one is that the whole debate assumes that we need a constructive version of special relativity in the sense of Einstein's famous distinction between constructive theories and theories of principle. This is how Wallerstein and Janssen present the distinction and rendition that Brown and Cooley overly approve, so we can use it here. In a theory of principle, one starts from some general, well-confirmed empirical regularities that are raised to the status of postulates. With such a theory, one explains the phenomena by showing that they necessarily occur in a world in accordance with the postulates. On the other hand, constructive theories aim to get at the underlying reality, please mind that term. In a constructive theory, one presupposes a set of models for some part of physical reality. One explains the phenomena by showing that the theory provides a model that gives an empirically adequate description of the salient features of reality. Okay, what about this? What is important here is that both parties agree in an evaluative comparison between, in an evaluation of the distinction. Both sides in the debate say that constructive explanations are explanatorily superior to explanations of principle. And that's why both parties say we need a constructive version of relativity theory. Otherwise, we would be in an explanatorily deficient situation. For Janssen, for example, principal theories are not explanatory because they do not aim at unraveling this reality behind the phenomena that feature in the definition of the distinction. And that's why Minkowski spacetime is the constructive theory that grounds Einstein's formulation of principle in 1905. He says something as strong as this, in this sense. Minkowski's 1909 paper did for special relativity understood strictly as a theory of principle what Boltzmann did for the second law of thermodynamics. It turned special relativity into a constructive theory, provided the concrete model for the reality behind the phenomenon covered by the principal theory. Brown shares the same evaluation, the same of the distinction. He says something like that, following actually Einstein, the man himself. Principal theories are typically employed when constructive theories are either unavailable, too difficult to build, or relatively unwieldy. For according to Einstein, when we say that we have succeeded in understanding a group of natural phenomena, we invariably mean that a constructive theory has been found which covers the processes in question. Okay, then what's the, for Brown and Pulley, what's the constructive counterpart of Einstein's theory of principle? Well, a Lorentz invariant fundamental quantum theory of matter. Okay, that for the first assumption in the debate. The second assumption is the following, that the debate at issue is supposed to be independent of the issue of the debate about space-time ontology. Why so? Why would we want to be independent of space-time ontology in this debate? Because the point at issue is it's about the foundations of our physical theory. So if we get involved in a philosophical, ontological, metaphysical debate that transcends that theory, then that can be a bit tricky, and we don't want that. What we are analyzing is special relativity per se. Or that's the approach I'm taking in this talk. I will see that Pulley Pulley takes a different perspective in other places. Okay, Janssen's view seems quite substantivalist. He says Minkowski spacetime explains Lorentz invariance. That sounds, at face value at least, substantivalist. But he says that no, I'm not a substantivalist. We don't need to be substantivalist to believe my interpretation. He says the following: special relativity as a physical theory is agnostic about the ontology of spacetime. Given that my argument is not about ontology, it had better be independent of whether one is a relationist or a substantivalist about Minkowski spacetime. He explicitly disentangles his position from spacetime ontology debate. Brown does something similar. The title of the joint paper, the Brown and Pulley paper, of one of the Brown and Pulley papers, is Minkowski spacetime, a glorious non-entity. That sounds rather relationist, of course, but in the preface of physical relativity, Harvey Brown says the following: my book is not designed to be a defense of the Leibnizian relational view of spacetime. Although I have sympathies for this view, in my opinion, the dynamical version of special relativity can be defended on much wider grounds, having essentially to do with good conceptual housekeeping. Pulley, I think in a 2013 work, takes a different stance. He directly addresses the debate between substantialists and relationists, and he describes the dynamical interpretation as a form of relationism. So I think that they have parted ways, at least up to some extent. But again, I want to, my perspective here is try to think about the connection between Minkowski spacetime and Lorentz invariance independently of spacetime ontology issues. Okay. Okay, why are these assumptions problematic? Independent from spacetime ontology, really? Can we do that? In the case of Janssen, I think it's pretty clear that we cannot do that. Why so? Unless some form of spacetime substantivalism is assumed, Janssen's argument cannot count as a constructive explanation of Lorentz invariance. Remember that the definition of a constructive explanation is an explanation that aims at unraveling the reality behind the phenomenon. Again, by definition, constructive explanation aims at unraveling the reality behind the phenomenon. If Minkowski spacetime is not a self-standing entity, then how can it constructively explain the dynamics of physical objects, or how can it constructively explain anything at all? Okay, in the case of the dynamical interpretation, that sounds rather relationist at face value. If we adopt a substantivalist setup, problems also come up. Remember the two arguments against the naive view. The first one was that physical objects don't have space-time feelers. But then the converse statement is also very convincing. That is, that space-time doesn't have sensors to detect the specific dynamics of those objects. So how could it adapt to the specific dynamics of those objects? The second argument said that, as a matter of logic alone, the structure of space-time does not constrain the form of dynamical laws. Again, the converse is also very convincing if this one is correct, which it is, by the example of Lorentz's ether theory. The form of the converse is the following. The form of the dynamical laws does not logically constrain the structure of spacetime. Again, Lorentz's ether theory is an example of this. It's an example both of the statement in Brown's argument and also of this, and it's also an example of this converse statement. Okay, let's take these two converse statements together. Let's put it in a substantivalist setup and let's see what happens. This is under a substantivalist setup. If Lorentz invariance cannot logically determine Minkowski structure, and if Lorentz invariance, Lorentzian dynamics, let's say, cannot be detected by this self-standing spacetime, then Lorentz invariance and Minkowski structure have to be independently postulated. Therefore, Lorentz invariance cannot explain Minkowski's structure. You have to put them independently, so you cannot draw an explanation going from one to the other. So, yeah, unless you are a relationist, it's very difficult to adopt the dynamical interpretation. That's the problem with the first demand, with the space-time ontology independence assumption. The second assumption, or I think I inverted the role, but doesn't matter. The first one was that the demand for a constructive version of special relativity. Why would we want that? Okay, I think that demand can be reconstructed by the following two principles. The first one is this. In general, given a realm of phenomena E for which there is a theory of principle TP and a corresponding constructive theory TC, TC is explanatorily more fundamental than TP with respect to that realm, to those phenomena. This is a rather plausible principle. It's actually the general default view concerning the connection between thermodynamics and statistical mechanics, for example. But this principle by itself is not enough to grant an absolute demand for a constructive version of relativity. Because if you take a look, this principle assumes that we have TP and TC, that we have both. But to ground the demand that I'm talking about, we need also this second principle. For every realm of phenomena for which there is a theory of principle, there is a corresponding constructive theory. This we cannot know. This sounds like an a priori statement. It may be super useful as a heuristic principle to look for certain kinds of theories, but we don't know if this is going to be the case for every single theory of principle that we may have. A theory of principle may be constructively, a theory of principle may not be constructively completable, and in our situation, the truncated view may not be constructively completable. What do I mean by this? Let me insist a bit. The dynamical view says that the constructive version of special relativity is a Lorentz invariance quantum theory of matter. Okay? Can that be the constructive version of special relativity? Okay, for that to work, Lorentz invariance itself must be a result in that theory. If we introduce Lorentz invariance from the outset by hand, then we are assuming Minkowski structure. This, I think, will be clearer a bit later on. And this is the situation right now. Actually, Michel Janssen is aware of this, and he makes this point in his paper. He says, in the two theories combined in today's standard model, the Weinberg-Salam theory and quantum chromodynamics, Lorentz invariance is assumed from the start as reflected in the common spatial structure of these theories. This illustrates how special relativity imposes a constraint on dynamical theories. But he also says this, that will be important in my conclusions. This is unlikely to be the final word on the matter. We can imagine that Minkowski spacetime will emerge in the low energy limit of some future theory of quantum gravity that does not include any spatiotemporal notions among its basic concepts. Such a theory would provide an answer to the question, why Minkowski spacetime? But we don't have it. That's why the dynamical interpretation is truncated. Okay, what I would like to propose is a different way to consider the connection between Minkowski structure and Lorentz invariance. It's fine, okay. What I say is that rather than to think about them as the cart and the horse, we should think about them as two sides of a single coin. We should not understand Minkowski spacetime structure and Lorentz invariance of laws in such a way that one has to explain the other. We better take them as two sides of a single coin. The arrow between them is not explanatory and unidirectional, but analytic and bidirectional. What do I mean by that? Don't take me too serious here, this is more of a rhetoric point, but I think it illustrates. Recall that analytic statement for Kant are those statements in which the predicate concept is included in the subject concept. Okay, that's why I say that put Minkowski structure as a subject and Lorentz invariance as a predicate, and you have an analytic statement. And I say that it's bidirectional because they can shift roles as subject and predicate in this statement. Why so? Because we can obtain either from the other. We can obtain Minkowski structure from Lorentz invariance, as Minkowski did. The Lorentz transformations leave this expression invariant. We take it as a line element, and we get Minkowski spacetime. On the other hand, to obtain Lorentz invariance from Minkowski spacetime, we start by postulating the geometrical structure. We then look for the group of transformations of Minkowski spacetime onto itself that will preserve that geometrical structure. This turns out to be the Lorentz group. Finally, using the geometrical structure of Minkowski spacetime, we define the class of inertial frames and show that any two inertial frames are related by a Lorentz transformation. This is from Michael Friedman's classic book on the foundations of spacetime theories. Okay. Then if we look for an arrow of explanation between these two features of the theory that we are addressing, we end up in a loop. If we ask, why is spacetime Minkowskian? The answer we get is because the laws are Lorentz invariant. If we ask, why are the laws invariant? The answer we get is because spacetime is Minkowskian. But if we understand them in the way I propose, this is just a non-starter. But then, what is the explanatory structure of the theory? What plays the explanatory role within the theory? I say that Minkowski spacetime is explanatorily relevant, but not with respect to Lorentz invariant, but directly with respect to physical phenomena. In which way? In a chronogeometric way. And what do I mean by that? If we understand Minkowski spacetime as a chronogeometric conceptual framework that renders physical phenomena intelligible, we get a nice explanation of relativistic physics. This sort of explanation is not of principle, it's more than that. We can get sort of chronogeometrical models from it. It's not constructive because it does not demand any ontological commitment regarding spacetime. Again, I'm considering Minkowski spacetime as a chronogeometric conceptual framework, not as a term that refers to an entity. This is more or less what I mean. In 1905, Minkowski structure expresses the default spatiotemporal behavior of physical objects. But Minkowski structure explains physical phenomena, not Lorentz invariance. They are, again, two sides of a single coin. Furthermore, the explanation that Minkowski structure allows is not constructive, but chronogeometric. This is still rather tentative. I intend to develop this notion in the future. This is just a starting point. And on the other hand, I disagree with Brown and Cooley that there is a need for a constructive version. Sorry, that's in Spanish. That a constructive version of special relativity. However, I don't say that there won't be such a thing. We can learn from the dynamic interpretation that we can take. We can take that view as an advice to keep an open mind with respect to the possibility that a fundamental theory may constructively explain both in one fell swoop, as Janssen said, both Lorentz invariance and Minkowski structure. So, thank you very much.
Yes, 5 minutes.
Yeah, try to be quick. So I wondered towards the end whether you were providing a defense of the dynamical view rather than sort of finding a third way.
Okay.
And the reason I think that's because partly in physical relativity says it shouldn't even be coherent to try and separate the symmetries of space-time from the symmetries of dynamical force laws. The symmetries of space-time precisely are the symmetries of the force laws. So there shouldn't be this like, if you understand what you're doing correctly, you shouldn't be able to entertain that as a sort of possibility. And then it's a mistake of the alternative view to allow for that. So then the question I would have is, if you're going that far, then when you come to, well, what explains something like Lorentz contraction, like an actual phenomenon, and then the dynamical view says, yeah, you should appeal to precisely the dynamics, the actual equations of physics, as opposed to space-time. I didn't hear anything in your view.
Okay, but my point is that those dynamics are Lorentz invariant. And Lorentz invariant is sort of the counterpart of Minkowski structure. And in order to explain that contraction, what I'm saying is that you don't need to say that space-time is an entity that is sort of determining that. That what the explanation we get with Minkowski space-time is a conceptual framework that allows us to make that thing intelligible. And I agree, yeah, it is the dynamics that explains the contraction. But that's kind of almost the same thing as saying that the contraction happens because the default spatiotemporal behavior of objects happens according to Minkowski structure. I would actually prefer to speak about Minkowski structure than about Minkowski spacetime. Minkowski spacetime has too much of an entity load. That's not what I want. And in that sense, yeah, I agree with the dynamical interpretation that we don't need spacetime as an explanatory entity. I completely agree with that part of the spirit of the dynamical interpretation. My point, as I want to stress out, underscore, is that I don't think that there is an explanatory connection between Lorentz invariance and Minkowski structure. That's my point. I don't know if that's...
Yeah.
Harvey, you want to?
Well, I just wanted to make a couple of remarks. One was about substantivalism, the role of substantivalism. And what I had in mind when I was saying that physical relativity is not really about substantivalism relations debate was a more modest understanding of substantivalism. The kind of substantivalism that was originally involved, for example, in the discussion of the whole argument, Herman and Wood, about the space-time manifold, not the manifold plus the metric.
Okay.
That's the first point I want to make. But the second point is, it's not true that Lorentz invariance and Minkowski spacetime are strictly two sides of the same coin. Minkowski spacetime has extra symmetries. It has the Euclidean symmetries, it has discrete symmetries like spatial inversion, spatial reflection. Now in the weak interactions, that symmetry is broken. So what would you say, what do you say, in the case of the weak interactions, what is the space-time structure?
Yeah, I prefer to remain silent about that question because that's physics that I'm not familiar with. But yeah, I suppose that what I know is that, yeah, in those fundamental theories, this I know only by informal conversations with people like Francesca Vidotto or something like that, in those theories, they still have a sense of Lorentz invariance, that even in a local way or something like that. But again, I'm not saying, when I said that there are two sides of a single coin, and I use this rhetoric device of analytic statement, what I exactly want to avoid is that I'm making a formal point with this. What I'm saying is that in the context of special relativity as presented by Einstein and Minkowski, if you assume that ideal clocks and ideal rods are truthful space-time surveyors, and the dynamics of these things are Lorentz invariant, then you get Minkowski structure as the expression of the default spatiotemporal behavior of this entity. That's all my point. Yeah, that sounds like an issue, but yeah, I don't want to go in a direction of making a point in the technical foundations of the theory. This is more from the point of view of explanation and those kinds of issues. But yeah, okay, that's super interesting to pursue, of course.
I'm afraid we're out of time. So thank you very much.